This is Annette Kirkland, and welcome to Beyond the Gates. This season, we're going to be highlighting ERDC's legacy of groundbreaking research and cutting-edge technologies. Join us as we explore how innovation continues to drive progress in military and civil works missions. And we're going to be speaking with Nick Josefik, and he's an industrial engineer with the Construction Engineering Research Laboratory, otherwise known as CERL. And he's going to be speaking about the H2Rescue, ERDC's novel approach to disaster relief. Good morning, Nick.
Thank you so much for letting me be a part of this. This is a good morning.
I love it. I love it. So we're going to be talking about some awesome innovation this morning, but I want you to tell me about yourself and your background.
Oh, excellent. Yeah, thank you so much. Yeah, so my name's Nick Josefik. I'm an industrial engineer working in the CERL energy branch, and I'm really lucky. I started here as a student. I was an industrial engineering student at the University of Illinois. And for all the students out there, make friends with the other students in your classes. I made friends with one of the other students who had a internship here at the laboratory, and he needed the team needed another worker. So I was able to get hitched on with the fuel cell team. I didn't know anything about fuel cells. His name was Jake. He asked me. He said, "Hey Nick, what do you know about fuel cells? Because we need more people on the team." And I said, "Jake, I don't know anything, but I can learn it before the interview. So let me do some reading, and next week I'll know some stuff about fuel cells." And I was able to get a student internship, work a few semesters and summers with the fuel cell team. Frank Holcomb is my mentor, and after I graduated, I was able to turn it into a full-time position. And then just continue working in fuel cell and distributed generation, and then just be able to work through the years. And that was all the way back in 1998 is when I started as a student, and just able to convert it into from a summer job or a student job into a full-time career.
That's a fantastic story. So what is your role at ERDC now?
Yeah, so I'm still with the fuel cell team. I'm now the team lead for the fuel cell, hydrogen, and distributed generation. So we do all sorts of research with different aspects of fuel cells. So fuel cells, electrolyzer, how to generate hydrogen, how to store hydrogen, demonstrations on both stationary and mobile fuel cells. And then what's really great about our fuel cell team is that we get to link up with the microgrid team, because we develop a distributed generation technique, and then we want to incorporate it with the microgrid team. So how can they incorporate it into the microgrid research? And then we also get to work with the building controls teams, because we've got this standalone distributed generation unit. How do we tie it in with the building controls and automation teams? So we're like the energy branch has a lot of great cogs that all work together, and I get to be part of it.
Fantastic, fantastic. So today we're here to talk about the H2Rescue emergency relief vehicle. Can you tell us about what it is and what its purpose? What is its purpose?
Yeah, definitely. So the H2Rescue is an emergency vehicle. So it's a box truck, a Class 7 truck that is Department of Transportation certified to drive on the roads. So it's a straight bed truck that is completely powered by a fuel cell battery combination. So no combustion engine. And it was planned to go into an emergency situation. It can drive into an emergency situation, pull up to it, and it can immediately begin exporting power. So we can plug in you come into a disaster area where there's no power, no water, anything like that. The fuel cell, you can pull up. The box is a warming and cooling shelter, so you automatically have your command center right there. You can start exporting power, and we can export enough power, 25 kilowatts for 72 hours, or you can back that down, and you could power things for weeks or a month on one tank of fuel, And 25 kilowatts worth of power is about 15 homes. So in that initial push in an emergency, we could be powering 15 to 20 homes for 3 days straight. Then we just refill our tanks and we can keep powering. And then the other cool thing is the fuel cell also generates water. So immediately coming into an emergency situation, we've got the warming and cooling center in the command center. We can bring, emergency supplies with us, fill up that box truck with emergency supplies, immediately start powering, getting power back to, a building or emergency services, and be providing water all in one vehicle. And we have enough fuel on the vehicle where it can travel about 1,500 miles into an emergency situation, and immediately we can start providing water, power, bring in those supplies. Yeah, so we have enough fuel in the H2Rescue to be able to drive about 1,500 miles to an emergency situation, and we can immediately bring power, water, shelter, and supplies into that emergency situation to get eyes on there for that first initial push to help people out.
Man, it sounds so important about all that you're doing with the research and everything concerning this H2Rescue vehicle. Now, how did the idea for H2Rescue come about, Nick?
Yeah, it's a great interagency collaboration where we have a working group with the Department of Energy, other Army laboratories, including GVSC, the Navy, Department of Homeland Security, FEMA, and we have this working group, Fuel Cell and Hydrogen Working Group. And multiple years ago, back in 2018, 2019, we started seeing more and more natural disasters in this country. So there were, unfortunately, very, very heartbreakingly, some wildfires sweeping different parts of this country. We've had, hurricanes and tornadoes where we were seeing that water and power are knocked out of these areas, and we want to make sure that we can, provide emergency services. There's plenty of branches of the federal government that provide emergency services during this. So in this fuel cell and hydrogen working group, we started coming up with the idea of how could we tailor the research that we were doing, the technologies that we're familiar with, to support these emergency services. So literally it came from just sketching it out on paper of how could we build a fuel cell battery hybrid vehicle, what kind of applications could it be useful for, where could it get the most applications in helping people inside of our country. So again, we were looking at that initial push of when there is nothing in, no eyes on the ground during an emergency situation. Mm-hmm. And it's not built for, solving every issue with the emergency situation, but literally you could drive into that emergency and provide all those things that I've listed already.
That sounds great. So this year we're celebrating how the labs came together 25 years ago to form one ERDC, one organization of experts across multiple disciplines. You're with the Construction Engineer Research Laboratory, but how have other labs and partners collaborated on H2Rescue?
Oh, yeah, great question. Yeah, that was right when I started as a student. We all went from our individual laboratories to get, teamed together to be more powerful, and it's been great. So with this one, this project has really been led out of the CERL laboratory because we have the hydrogen, or the energy branch, and the hydrogen research team is out of here. But we've been able to collaborate. There's been more and more research coming out of CERL because we've been working on fuel cells, and then how do we adapt that to the cold regions? We're going to have more and more activity up there. So CERL has really been getting more active on the fuel cell and hydrogen research side also. Mm-hmm. And then down at the Vicksburg campus, there's some cybersecurity research being done, and we're able to tie those in from that aspect of the communications and the security. We've also been able to work with other Army labs, the GVSC, the Ground Vehicle Systems Center, another great partnership between Army labs. I know it's not ERDC, but they have a lot of fuel cell and vehicular research too that we've been able to lean on their expertise also.
Well, teamwork makes the dream work. So,
Yes.
so what are some of the advantages of using hydrogen as a fuel source? And is using hydrogen for fuel a new idea?
Yeah. So hydrogen is an energy storage medium. We're always looking for how do we store energy. So a lot of times we've been using fossil fuels as our energy storage medium, but we've been doing research to use hydrogen as that storage. So some of the interesting things is a hydrogen fuel cell can be twice as efficient as a combustion generator. So if we use hydrogen as our fuel, we don't have to bring as much fuel with us when we go into these emergency situations, or our fuel will last us much longer than the liquid fuel that we need for our combustion generators. The other interesting thing is when we use pure hydrogen in our fuel cells, the only byproduct is water vapor. So again, if we're looking at the greenhouse gases mixture of what our energy providers are making, we can reduce some of those greenhouse gases by using a hydrogen fuel cell. And fuel cells aren't a new technology. Mm-hmm. They were invented in the 1800s and called the gas battery. And
what?
Yeah,
I had no idea.
And so research has been going on for many years, but of course, like lots of things, we've made them much more efficient, much more user-friendly, much more robust so they've really moved out of the laboratory and into the real world. Fuel cells can be used for the vehicles in this case. We use them for stationary applications. They've been on the space shuttle. Mm-hmm. They're used in small, tiny little applications, to replace batteries that need very long durations. Mm-hmm. And our laboratory has been doing fuel cell research since the mid-90s, just here at our laboratory. But yeah, fuel cells were invented in the 1800s, really old technology.
Well, I did not know that. So what makes H2Rescue different from other emergency vehicles or generators? Yeah.
So the unique thing about the H2Rescue, again, it's a greener technology. It's greenhouse gas emissions are just water vapor, and the vehicle itself is also your power generator. So as I've mentioned, when the H2Rescue pulls into an emergency situation, you park the vehicle, you can immediately start plugging your power needs directly into the vehicle. Unlike traditional how we do the emergency situations, you drive a vehicle in, you pull a trailer that has generators on it, you pull a trailer that has fuel on it. You have to have a technician to set those generators up safely and to operate those generators. We can eliminate that step by just pulling the H2Rescue into that situation and start plugging things in. So we only have that one. Our vehicle becomes our generator.
Right.
Also, the vehicle produces water that can be used on site, and it produces heat, so we can have that warming and cooling shelter. So we're really knocking out multiple items with one piece of technology. So instead of trucking in, bringing in a generator and a fuel tank, we can just drive the vehicle in and pull a fuel tank with us, and we could be set up for weeks or months, exporting power, exporting water, and with only water as our byproduct.
That's
water
awesome.
Vapor.
How have you put H2Rescue to the test, and what were some of the challenges or successes that you have encountered?
Oh, excellent. Yeah, we've had a very fun summer. So we've done two different field demonstrations where what we would do is we drove the vehicle 180 miles through mixed terrain. So we drove it on city streets, we drove it on highways, stop and go traffic. We got stuck in a traffic jam. And we had the vehicle completely monitored up, so we could see the performance of the vehicle through the entire time, and we were measuring, fuel consumption, temperatures, everything about that fuel cell while we were driving. So we were going up and down hills, and we drove in extreme heat. We were in one of the tests, we were over 115 degrees outside. And again, we really wanted to monitor the performance of how well it did. Mm-hmm. And then we got down around 40 degrees was the coldest. We haven't done any cold weather testing yet. But so we did one demonstration in California, and that was a much warmer climate. Again, we went up and down some hills. And after we did the driving portion, then we started doing the power export. So we just turned the fuel cells on, and we started exporting power for 72 hours. And just to show the durability of the fuel cell, that we could be powering those approximately 15 homes for 72 hours straight without a hitch. Mm-hmm. So we did that demonstration, and everything went great. We had a lot of fun and late nights, because again, once you turn the fuel cell on, the vehicle had to be staffed 24/7 for 72 hours. So some pizza and some long time sitting there, right?
Coffee, lots of coffee.
Yes, lots of coffee. So we did one of those tests in California. Mm-hmm. Then our next test, we took it out to Golden, Colorado, to the National Renewable Energy Laboratory. Mm-hmm. And so we partnered with DOE and NREL, and they have a fueling station there. So we got to use NREL's own fueling station to fill up the vehicle. And then we tried to replicate that test again. And so this time we're doing it at altitude and driving up and down the mountains. And one of the interesting things that we found was that at above 6,000 feet, we started starving the fuel cell for oxygen. There's just a lot less oxygen up there. Mm-hmm. And it was very interesting. We found out that as long as the fuel cell was running, there's fans blowing and we could feed enough oxygen to it. But if we completely shut down the fuel cell and the vehicle, and then we tried to start it, just like how, your regular car, it's a little harder to, one of the hardest things it has to do is start from a cold stop.
Right.
When we went from a cold start, it gave us some error saying we weren't getting enough oxygen, and we were it's around 6,000 feet. We're right at the limit of how much oxygen is in the air that could start the vehicle from a cold stop. So we know we have to upsize the little intake fan a little bit more if we're going to turn that vehicle on, from a cold start above 6,000 feet. So that was definitely a good lesson learned.
Eye opener, right?
Oh yeah. The other interesting fact of when we were doing the demonstration out in Colorado, we had to cut that demonstration short a little bit. We were doing the power export, and this is a lesson for all researchers, right? Mm-hmm. You can't control the weather,
right?
So we were outside. We were doing our power export right in the middle of the test, and the tornado sirens start going off.
Oh no.
And again, for the safety of researchers and team members, we had to turn the vehicle off. We had to go shelter in place, mm-hmm. or shelter in some buildings. And I know the joke is that it's an emergency vehicle and why were we, running, but this was a demonstration and it was researchers. So we have to have, human safety first,
right,
above all things. But we did have it was a very unique experience. I guess they don't get tornadoes very often in the Golden, Denver area, but the tornado sirens were going off, and we did have to shut that test down a little early and go inside the building. But it just for all the ERDC researchers out there, right? We can't plan for everything.
No.
And sometimes change our plan.
Did you start back after all that was over, or was that just a wash?
We did get some more runtime, but unfortunately, there was about 3 days worth of storms, and so it really disrupted the time limits that we had on the to be able to do the test and things like that. But we did get great usable data.
Mm-hmm.
We just didn't get as much of it as we'd originally hoped. But I think a tornado is a good reason to cut a test short.
Oh, absolutely, absolutely. So, what are the next steps for H2Rescue, and what are your future plans or goals?
Yeah, so we've got some great things coming up with H2Rescue. So we're going to do some long duration testing of the fuel cell. Just get some run hours on it. Run a full tank of fuel. Let's see how far we can drive, how much power we can produce, and just do some more duration testing with that. Mm-hmm. And then in the next round, what we're planning on doing some other really unique things. So right now the fuel cell produces pure water, H2O. We have to work through some legal issues. The lawyers are rule the world, I guess. To get that certified as potable so that we could drink it. Mm-hmm. We've taken some samples of it. It's pure H2O, but we've got to work through some paperwork to make sure that we can get it certified as potable. Mm-hmm. And that way, in an emergency situation, we could, safely drink it. Again, it's getting that certification and that stamp to make sure everyone's safe. So we're going to do that, and then we're going to have some multiple showcases. We're going to take it around to different organizations, different field demonstrations that maybe the Army or other organizations. So we're looking for Army, DoD applications or emergency preparedness demonstrations where we could bring the vehicle to it and show our demonstration on how it operates. So we're definitely looking for more applications over the next year where we could take it.
That sounds great.
Yeah. And then we've got some other research applications that we're doing. So we're working with DHS and FEMA for a version, to plan a version 2.0, based on all the lessons learned that we learned from version 1.0. Mm-hmm. We've found a number of areas where we can more closely align with the DHS and FEMA, the vehicles that they currently have and are using, and how could we integrate it into their vehicles.
Right.
And then we're also looking at working with the microgrid standards. So when we pull up to a building, we want to make sure that we have all of the standards and safety protocols so we could tie directly into a building and power that building. And so that's working with the ERDC. There's an ERDC research group working on these technical microgrid standards that'll be standards across the country. And, version 2.0, we want to make sure that we hit all those metrics so that we're compliant with the TMSC.
That sounds great. That's a lot of goals and a lot of things going on in the future for H2Rescue. But I have a question. How much water are you talking about that can be produced? I don't know if you've hit on that, but that's just like my curious head question.
Sure. So we're not talking thousands of gallons.
Right.
But so in a 72-hour period, we could theoretically create, like 300 gallons of water that could be used on site.
That's
so
fascinating.
enough for some drinking or, some washing, things like that. And then the water is produced as long as we're running the fuel cell. So it's always, trickling out, a few, gallons, per hour while we're operating that fuel cell. So we're always generating more water as long as we're operating. So, yeah.
I just learned that because myself, I attended a couple of these showcases that you guys had a few months ago, and I did not realize that it produces water. So that's good to know. Hence the word hits H2Rescue, right? So,
yep.
So what would you like listeners to learn from this valuable conversation?
Yeah, so definitely fuel cells and hydrogen are an option. There's going to be multiple solutions for every kind of research problem that we come up against. So the support of alternative fueled vehicles and that kind of research is really important to keep pushing forward. Fuel cells, hydrogen, we hope have a niche that they can fill, and then there's going to be lots of other alternative energy sources that we can use. So we want to build a nice portfolio of different energy sources, energy combinations to solve this country's energy problems. And then we need researchers thinking about how do we support these natural disasters. Like I said, this whole project just came from a group of researchers seeing these natural disasters around and then talking about with the research that they're doing on how we could apply it to these emergency situations. So I know in ERDC there's lots of good research out there, and I'd encourage those researchers to look at how can they apply their research. Maybe it's a little off the wall or something, but in these emergency situations to help the citizens of the U.S. here and around the world, because there's lots of opportunities and we need to do what we can to help these emergency situations.
Well, sounds great, Nick, and thank you for all you do in your innovation for H2Rescue.
The U.S. Army Engineer Research and Development Center, or ERDC, is the premier research and development center for the U.S. Army Corps of Engineers. Hello, I'm Carol Coleman, and I would like to share with you how ERDC makes the difference. Established in 1998, the ERDC is home to more than $1 billion worth of world-class facilities located in 7 laboratories and multiple field sites across the country. The organization's main campus is situated on the historic Waterways Experiment Station in Vicksburg, Mississippi, and consists of the Coastal and Hydraulics Laboratory, the Environmental Laboratory, the Geotechnical and Structures Laboratory, and the Information Technology Laboratory. ERDC also operates 3 laboratories not located on the West Campus, including the Construction Engineering Research Laboratory in Champaign, Illinois, the Cold Regions Research and Engineering Laboratory in Hanover, New Hampshire, and the Geospatial Research Laboratory in Alexandria, Virginia. Each laboratory has their own unique mission and operates as integrated teams of engineers and scientists to address a broad range of science and technology issues. The Coastal and Hydraulics Laboratory, or CHL, addresses an entire spectrum of water resource challenges. Their mission is to deliver solutions to our nation's most challenging coastal and hydraulics problems. As part of the CHL, the Field Research Facility, or FRF, is a U.S. Army Corps of Engineers field site located in Duck, North Carolina. The cornerstone of the FRF's contribution to coastal research has been its long-term data measurements that stretch back to 1977. The long-term measurements have made the property one of the best studied beaches in the world. Providing solutions for tomorrow's environmental challenges, the Environmental Laboratory, or EL, is ERDC's primary center for ecosystem science, ecosystem technology, and environmental resiliency research. The laboratory is home to the Aquatic and Wetlands Ecosystem Research and Development Center and the Hazardous Waste Research Center. ERDC's Geotechnical and Structures Laboratory, or GSL, supports our nation's defense, security, public safety, and infrastructure. GSL is home to the world's largest heavy vehicle simulator, the Centrifuge Research Facility, and the Advanced Blast Load Simulator. In today's fast-paced digital environment, the Information Technology Laboratory, or ITL, provides innovative solutions to solve the nation's most complex and challenging IT and computational issues. The laboratory's Supercomputing Resource Center is one of only 5 Department of Defense computing centers operated by the DoD High Performance Computing Modernization Program. For more than 50 years, ERDC's Construction Engineering Research Laboratory, or CERL, has supported the Army's ability to design, build, operate, and maintain its installations and contingency bases. Located in Champaign, Illinois, the laboratory is home to the Triaxial Earthquake and Shock Simulator. ERDC's Cold Regions Research and Engineering Laboratory, or CERL, delivers environmentally relevant and transformative engineering solutions to test, evaluate, and improve infrastructure and equipment, particularly for use in cold regions. Located in Hanover, New Hampshire, the laboratory is home to the Frost Effects Research Facility, the largest refrigerated warehouse in the United States. The Permafrost Tunnel Research Facility is a U.S. Army Corps of Engineers field site operated and maintained by ERDC's CERL. The tunnel, located just outside Fairbanks, Alaska, is a unique natural research facility with features up to 40,000 years old. ERDC's Geospatial Research Laboratory, or GRL, located in Alexandria, Virginia, serves as the Geospatial Research and Development Laboratory of the U.S. Army Corps of Engineers. GRL is the only dedicated geospatial research and development laboratory in the entire Department of Defense. As the premier research and development center for the U.S. Army Corps of Engineers, ERDC has unique, world-class equipment and facilities. To learn more how ERDC discovers, develops, and delivers innovative solutions to the nation's toughest challenges, be sure to listen to Beyond the Gates on News Talk FM 107.7 on Thursdays at 8:15 a.m. and 9:10 a.m. or check out past shows on vicksburgradio.com. We discuss exciting research with representatives from one of the 7 ERDC laboratories, and they describe how their projects are important to the community, the region, and the nation. Again, I'm Carol Coleman with ERDC. Thanks for listening.
The U.S. Engineer Research Development Center, or ERDC, is the premier research development center for the U.S. Army Corps of Engineers. Hello, I am Jared Eastman, and I would like to talk to you about how ERDC contributed in the Second World War. America's entry into World War II had a dramatic impact on the Corps of Engineers and the Waterways Experiment Station, which would later become ERDC. WES quickly changed its focus from civil works to military projects. Changing priorities, transfers, and call-ups for military service profoundly influenced the station's operations. WES personnel focused their efforts on building training facilities for the Army, harbor and channel improvements for the Navy, and revolutionized airfield construction to support the Army Air Corps. Model studies, the hallmark of WES, were made of selected landing sites in North Africa, Italy, and France. Models were also made to the benefit of Allied bombing crews, such as the V-1 and V-2 rocket launch pads and the German ball bearing works in Schweinfurt. Research that happens at WES was crucial to the success of military operations around the globe. Research that happened at WES was crucial to the success of military operations around the globe. In their drive to liberate Western Europe and invade Nazi Germany, Allied forces had to cross numerous rivers that posed formidable technical difficulties. As it was anticipated that no permanent bridges would be left standing, crossings were to be made on pontoon or pneumatic float bridges. Although American pontoons could carry heavier loads in low-velocity flows than their British counterparts, they performed poorly in heavy-velocity flows, like those that would be encountered in Europe. In their drive to liberate Western Europe and invade Nazi Germany, Allied forces had to cross numerous rivers that posed formidable technical difficulties. As it was anticipated that no permanent bridges would be left standing, crossings were to be made on pontoon or pneumatic float bridges. Although American pontoons could carry heavier loads in low-velocity flows than their British counterparts, they performed poorly in high-velocity flows, like those that would be encountered in Europe. WES personnel worked around the clock, 7 days a week, from June until November 1943, to develop and test various designs that would reduce skin friction between the pontoons and water and prevent overtopping of the bow or sides. On the night of March 23, 1945, companies from the 17th Armored Engineer Battalion utilized the new design to construct treadway rafts to prepare the crossing of the Rhine River south of Wesel. Bridge construction started at 9:45 in the morning, and by 4 p.m., the first truck crossed into Germany. The bridge, comprised of over 1,152 feet of M2 treadway and 93 pneumatic floats, was completed in just 6 hours and 15 minutes. Air power was a decisive factor in Allied victory in World War II, both in Europe and in the Pacific. Yet, as late as 1939, most runways, taxiways, and aprons were either sod fields or rigid pavement that could not withstand the anticipated traffic levels and stresses produced by heavy military airplanes being developed. To address this crisis in airfield design, engineers and scientists looked to asphalt-based surfaces to accommodate heavy bombers of the time, such as the B-32 Dominator and the B-17 Flying Fortress, some of which could weigh in excess of 120,000 pounds. WES quickly emerged as a world leader in flexible pavement research, as well as the development of expedient surfaces such as landing mats for rapid construction of temporary or emergency airfields in combat zones. The revolutionary developments in airfield design produced at WES were key to gaining air superiority and would become the standard for commercial airfields. To learn more about how ERDC discovers, develops, and delivers innovative solutions to the nation's toughest challenges today, be sure to listen to Beyond the Gates on News Talk FM 107.7, Thursdays at 8:15 a.m. and 9:10 a.m., or check out our past shows on vicksburgradio.com. We discuss exciting research with representatives from one of the 7 ERDC labs, and they explain how their projects are important to the community, the region, and the nation. Again, I am Jared Eastman, ERDC Public Affairs, and thanks for listening.
The U.S. Army Engineer Research and Development Center, or ERDC, is the premier research and development center for the U.S. Army Corps of Engineers. Hello, my name is Claiborne Cooksey, and I would like to talk to you about how ERDC makes a difference. Did you know that ERDC started a robotics program for high school students more than 20 years ago? We call it Siege Robotics, and our competition team name is FRC Team 456. The FRC stands for First Robotics Competition and is part of a nonprofit organization that was founded to promote science, technology, engineering, and math, or STEM, in America's youth. Our team is currently made up of about 35 students from across central Mississippi. The team has several advisors leading the way, including ERDC's very own Jenny Dickerson, who recently won the Woody Flowers Finalist Award. This prestigious award recognizes mentors within the FRC who lead, inspire, and empower young people by using their excellent communication skills. Another one of the team's advisors, Chuck Dickerson, also won this award in 2015. FRC Team 456 works together to construct a robot to compete in high-intensity events at competitions where the team is judged for robot effectiveness, strategy, collaboration, and determination. Since 2000, the team has competed in more than 10 states, winning many competitions and receiving more than 50 awards along the way. Because of this amazing opportunity, students in our community can experience science and engineering at work in the real world. This hands-on after-school adventure allows the students to gain skills that will last a lifetime. Many team members have carried on pursuing degrees in STEM, and some have even returned home to begin their careers at ERDC. You may remember previous guests on the Beyond the Gate show, Alan Katzenmeyer and Anna Jordan. They were both involved in Siege Robotics as high school students, and now they are chiefs in their labs and leaders in their fields here at ERDC. Awesome, right? Remember, it all starts here. Siege Robotics has been sponsored for years by Energy, International Paper, City of Vicksburg, Atmos Energy, Vicksburg Warren School District, and DoD STEM. If you know a high school student who would like to apply for ERDC's Siege Robotics team, visit siegerobotics.org. To learn more how ERDC discovers, develops, and delivers innovative solutions to the nation's toughest challenges, be sure to listen to Beyond the Gates on News Talk FM 107.7 on Thursdays at 8:15 a.m. and 9:10 a.m., or check out past shows on vicksburgradio.com. We discuss exciting research with representatives from one of the 7 ERDC labs, and they describe how their projects are important to the community, the region, and the nation. Again, I'm Claiborne Cooksey with ERDC, and thanks for listening.